Bismillahirrahmanirrahim. Assalamu alaikum and hello everybody. We are going to start our lecture number 24 and that is about identifying the risk. So by this point in time we have talked about risk management a bit detail. Now we have completed first process in the last lecture and we are going to start our second process of risk management. Remember, there are 6 processes available in risk management as far as PMI's risk management framework is concerned. So let's talk on that. But before we start identify risk process of risk management, we will have a summary of the previous lecture. In previous lecture, we have talked about the objectives of plan risk management. Risk management plan was discussed, and then when should we start risk management? So the answer is as early as possible. In most of the cases, we actually start the risk management processes even in initiating phase while we are uncovering initial risks and assumptions and constraints. Then there is a cost attached to risk management, so we should be very clear of the effort we are putting into managing risk, okay? And then plan risk management process was discussed. What are the inputs, outputs and tools and technique available for risk management, plan risk management. And then what is included in risk management plan, we have talked about in detail in previous lecture on that. So let's start the second process, and that is identify risk. So our risk may be a loss, a risk may be a profit, a risk may be a good, a risk may be a bad, but you know, most of the time people usually call it a bad thing. But you should have this concept very clear that the risk may be an opportunity which you need to, you want to actually exploit. So a risk cannot be managed. First thing is very important. You cannot manage your risk if you cannot identify it. So consequently, after risk management planning has been completed, the first process in the iterative project risk management process aims to identify all the knowable risk to the project objective. Remember, we do not use possible because by that point in time we are in need of only those risks which are actually affecting the very objectives of our particular project, okay, not all the possible risks. So if you are into a construction industry and the people over there have identified like a list of 1,000 risks, okay, so then you have to find out which risks are quite related to your particular project. Those may be like 20 or like 100 or 200, but not 1,000. So you are not going for all the possible risks. You are going for all the knowable risks. You are choosing between those. So knowable means by that point in time, while you are actually taking up this exercise, which are known to you by that time. Okay, you have chosen 200 risks out of 1,000, but afterwards, during the execution, you have come across, okay, we want to have included another 50 risks which have surfaced now, or which are going to surface in a few time. So but initially you will stick to 200, okay, you won't go for the 1,000. And there is another word that is iterative. Risk management is iterative, okay, and I have explained in the previous lecture that you will follow a sequence, okay, then you will keep identifying the risk throughout the project life cycle. And the question is identifying all the risks, okay. You want to go and just dig it up and find this trio of having a huge list of risks. Do you want that? So the answer is this slide. So it is, however, impossible to identify all the risk at the outset of a project. over time the level of project risk exposure changes as a result of the decisions and action taken previously in the project, internal change, and of externally imposed change. So all these things actually trigger for new risk, elimination of the older risk, and change in characteristic of existing risk. So there may be so many different things. So you cannot identify all the risk. There is no such tray part available where you can have all this tray. Okay. Okay, first thing first, what is the objective of identify risk? So the answer is very straightforward. You want to identify all the risk. That is very objective. And all the risk, you mean the ones, the events who are having positive or negative, or who may have positive or negative impact on your objectives of your project. So the purpose of risk identification is identify risk to the maximum extent that is practicable. Not 1,000, just 200 out of 50. Okay. So the fact that some risks are unknowable or emergent requires the identifier risk process to be iterative. Repeating the identify risks process to find new risks which have become knowable since the previous iteration of the process. So these are few considerations when you go for identifying the risks. Okay. So identify and response risk. When risk is first identified, potential responses may also be identified at the same time. So if we have identified this one risk that one of the laborer may fall from the 8th story, so what would have been the responses? Okay, first we want to have better safety practices available on the site, or we want to give a safety belt to this laborer, and we want to have a net around risky site and stuff like that, you know. So you are having a potential responses list as well. So these should be recorded during the identify risks process and considered for immediate action if such action is appropriate. Where such responses are not implemented immediately, these should be considered during the plan risk responses process. So most of the time you are doing good while this phase is concerned, but then at times you want to just let the things go to the next process, and that is qualitative analysis, quantitative analysis, and then you plan responses. So this is good if you are having a very good idea what you are going to do at this very process of identifying. And early identification, now there are, while we were talking about risk identification, there are 3 types of identification. So we are going through these. So risk identification should be performed as early as possible in the project life cycle. So early risk identification enables key project decisions to take maximum account of risk inherent in the project and may result in changes to the project strategy. So if risks are identified initially in the very early stage, you can even cancel that project, okay, so these are the risks, we cannot have any profit out of this project. So what's the big point actually wasting our energies and resources over there if we are not going to have profits over there? So early risk identification can help you in that. And early identification also maximizes the time available for development and implementation of risk responses, which enhances efficiency, since responses taken early are often normally less costly than the later ones. So if you can have safety belts available to these labor, so you know, so with the breakage of this shuttering, this laborer will stay over there, and you can have some other means to bring that guy back to the land. But if those safety measures are not taken up, so that may lead to serious injury or even death. And then there is another concept, that is iterative identification. So since not all the risk can be identified in initial stage, so it is essential that risk identification is repeated throughout the project life cycle. So this should be done periodically at a frequency determined during the plan risk management process. So remember the frequency part, how much we have to have this frequency. So there is another definition, but we are going to, and that is emergent identification. So in addition to invoking the identify risks process as defined in the project plan, the project risk management plan process should permit risks to be identified at any time, not limited to formal risk identification events or regular reviews. So the project team members should be, again, frequency, method, and all the stuff we have discussed earlier is coming into play in these slides as well. Risk, we just want to identify those risks which are going to affect our objectives. Okay, so risks only exist in relation to objectives. So if some risk or some event or bad or good is available, but that is not affecting the objectives of our project, then we should not consider waste our time evaluating that. So each identified project risk should relate to at least one project objective: time, cost, quality, scope, etc. And through studies we have learned that the most serious project risks are, as far as so many other parameters are concerned, the most significant project risks are those associated with its scope. Identifying scope risk reveals whether the project is within ken or out with the team's capabilities. Early decisions to shift the scope or abandon the project are essential on projects with significant scope risks. So either we want to contract it out, we do have the suppliers, or we do have subcontractors, or we do have sublet it to some outsourced project to somebody else, or we just want to abandon that project because of the scope risks. So that is very much dependent on how responsive and repulsive we are, and how early we are actually taking up those decisions. And sources of scope risk, while the categories of scope risk are many, two important ones are change and defect. So scope risk can be broadly further divided into categories: change risk and defect risk. Okay, so change risk is about, you then are talking about scope creep, and then scope gaps, and then scope relationship. If your scope is dependent on something external, then that is a very good thing to identify, and there is a big risk hidden over there. So one of the example is Dreamliner 787 and Boeing project, and so many components were dependent on so many things. So there is a case study available if you want to Google and have a look on that, what was the factors which have actually affected the project's life cycle. Okay, and then the second type of scope risk are defect risk, and that is new technology has arisen, and component malfunctioning, then you have to redo that, and then component integration. So these are two types, but there may be more, but there are two types of categories. So defining deliverables is very important as far as scope risk are concerned. So first thing is collecting requirements, So these guys are actually showing over there that they are taking up the pieces from the different stakeholders, and now you are going to collect them through those stakeholders and put into one piece. Highest care should be taken in defining the deliverables. What is part of your project and what is not part of your project, and what is the final deliverable, what is included and what is not included in that. Written documents should be prepared. The writing, including charts, diagrams, tables, should be specific, clear, objective, unambiguous, accurate, comprehensive, and all stakeholders and project contributors should agree and sign on, and they should have shown the similar understanding of the things. And the process of defining the deliverable, so defining the deliverables thoroughly is one very powerful tool for uncovering potential scope change risk. So defining the deliverables for the project gives the project manager and the team the first indication of the risk in the proposed project. So if the deliverables were not defined earlier, and now one stakeholder is there and customer is there, and he is saying that, well, I do not want that product, I just want it in something different way, so that is kind of a big risk then. And perspective to include in defining the deliverables. Consider the project over the entire life cycle. So identifying people who will get involved in the various stages of or functions within the project. So typical stages and functions are design. So these are few steps which so by dividing your project into these phases, you can have a better understanding of the probable influencing stakeholders in that very phase of your project. So as far as design is concerned, so you are dealing with engineers, or you are dealing with the architects, or you are dealing with economists, or you are dealing with statistic people. They are having all these things designed for you. By that time, people from the execution are not that influencing, and then there is a stage of procurement. Then the design people are done with their job, and they have reduced their level of activity to minimum, and now there is a procurement guy. He is actually working on, and the level of effort he's put in is quite high. So when he's done with the procurement, his role is diminished or decreased. Then contracting is there, and then there is another phase, that planning. Now project team comes to play. Then there is a documentation stage, then there is a construction stage, then there is a billing stage, then acceptance stage, then defect liability certificate stage, then taking over certificate. So these are few stages which can be considered as far as construction project is concerned. So you can have more of a list, and so entire life cycle, if you can actually divide your project into these phases, and you can have very good idea which stakeholder is going to influence my project at what time. Okay, so accordingly you can manage those risks associated with that stakeholder, and hence the scope. So topics for the process of defining deliverables. So from the participants, collect a list of topics or get the list of boilerplate. It helps if a number of questions can be formulated for each topic. Okay, and what is that? Example topics and question 1. So first question is, how does this project contribute to the stated high-level business objectives? So whether this project is in alignment with the business strategy or organization. So this is a very, very critical question. So if your organization is actually taking up these projects to enhance the literacy rate of one very particular area, and one of the component is the construction of schools, and but what if you have started building commercial market. Now that is not aligned with the overall mission, vision and objective and goals of your organization. Then the second question may be, has the project team captured the ultimate end user requirements? So for that very particular school area, you cannot go over there and teach French straight away, because their native language is Pashto, and their national language is Urdu, and their business language is English. So what is the big point if you are going to teach the French to these guys or these children? Okay, so such decision, there is a French community living over there, and they want to have linkage. They want to keep their linkage with their language as well. Now you have very good captured this requirement. Now that French is quite okay with that scenario. So it will give you user and customer needs, and then you can ask this question that, has the team identified all relevant regulatory, environmental and manufacturing requirements, as well as relevant industry standards? So if you want to construct a road, who would be your regulatory bodies who you may have interacted with? So if you are running an NGO, whether you are in need of an NOC from police and other departments in that area, so you want to complete all this R&D beforehand. And then if you are constructing this 80-story building in Islamabad, have you taken the approval of CAA or from environment authorities? So you want to have the compliance of all these things. Then has the team identified both the current and the projected alternatives to the proposed deliverables? So you can you identify and can you have what is the criteria for the completion? So if you are focusing on this very alternative and you have not considered other alternatives, so your project is kind of not doing good. So you should have appraisal and alternative analysis as well. So is there a clear and compelling benefit-oriented project objective that supports the business case for the project? So what is the positioning of your project? Another question you may ask, does this project team have an agreed upon hierarchy of measurable priorities for cost, time, quality and scope? So decision criteria should be very much clear. And there may be another question that are logistical requirements understood and manageable, including machinery requirements and equipment availability on time and other things, other equipment and material or computers or stuff like that. So delivery part of your risk management or your scope management should be questioned. So does the management hierarchy collectively support the project, and will it provide timely decisions and ongoing resources? So sponsorship, you are questioning the sponsorship of your project. And then does the project have and will it continue to have the staffing and funding needed to meet the project goals with the allocated time? So you are questioning the resources availability in that question. So these are a few questions. And then has the team assessed the overall level of risk it is taking? Are technical and other exposures well documented? So the list can go beyond that. So you may have another questions to be asked to have better understanding of scope or type of risk, identifying those. So additional requirements, maybe completion criteria, we have talked about that, project and acceptance criteria. So planned project start, staffing requirements in terms of skill and experience, cost, rough order of magnitude, detailed requirements, functionality, usability, reliability, performance, portability, other significant issues. The data customary and are appropriate for this project. So for that we use these few tools for the assessment of the risk, and a number of tools are available for that, and here are only three which are more commonly used are shown over there. So first one is risk framework, and the second one is risk complexity index. The third one is risk assessment grade. So as far as projects are tangible, tangible projects are concerned, we use these two methods. Those are called risk framework and risk complexity index. Tangible deliverables mean constructing a road, or constructing a house, or constructing a mosque, or constructing a monument, or constructing something else. Similarly, developing a software, and developing a database, or developing a website. But then it comes to imparting education to group of people, or eradicating or eliminating or reducing the poverty level from a community. So these are quite subjective goals and objectives. So these are intangible deliverables over there. So for intangible deliverables we use risk assessment grades, and for tangible deliverables we use risk complexity index. So let's talk about a risk framework. So to start, delineate important aspects of factors of the project. For each factor, assess the amount of change required by the project. This assessment is binary, small or large. So for example, consider as important the following three factors of one project. So technology, so you will be using, you want to delineate important aspects of factors. So what is amount of change of that project? So if you are working that project or that kind of job since 10 years and your organization is very matured, by that time your change in technology is small, and usage, the user, how predictable your user is, so that is kind of unpredictable, so you are using that large. And construction or the methodology, so that is very much apprehended, so that is small. So that project, 2 smalls, 1 large, so that is 2 and 1 and out of 3. So you can call it less risky than if you are having large, large and large, more risky. So this is it. So this method can be used in that fashion. So with respect to each of these factors, one or more questions could be posited as follows. Technology: does the project use only well understood method and skills, or will new skill be required or developed, small or large? So you can have one. As far as usage is concerned, will the deliverable be used by someone or by class of user you know well, or does this project address a need of or unknown to you? So small or large scale, you can choose one. Construction methodology: are there any unresolved or changing manufacturing or delivery channel issues, a few or many? So you can use that. So this is how you can have a better understanding of the deliverables as far as risk is concerned. Then risk complexity index is another method. So this tool for measuring project risk is used for technical project. Just like construction or mechanical project, some electrical project. So you have to develop this index as follow. So index is this formula is given over there, like technology, architecture and construction. So this example is considering only 3 parameters. So you may have used like 10 parameters rather than the 3 we are using over there. So you can have used and then that is to be multiplied by scale. So what is the scoring for each parameter, like measure each of 3 parameters. So if these are the parameters, technology, architecture and construction, so measure each parameter on a 6-point scale. So the scale number 1 is 0, total understanding, put 0, and put 5 completely new, technological feasibility is in doubt. ठीक है? So for that, अगर इस तरह की चीज़ है कि आपको बिल्कुल पता ही किसी चीज़ का नहीं है, तो फिर आप यूज़ करेंगे नंबर 5, put over there. So 5 for architecture, that is a minor extension, so you will use 1, so यहाँ 1 डाल दें. And for construction, so almost certainly possible, but innovation needed in some areas, so you are in need of 3. So you add this thing up and multiply by scale factor. So as we are using 3 parameters and we are having index factor up to 100, so if that is 3, so what will be the scale factor? So scale factor in that case will be, so what could be the maximum score for that? That is 5 and this 5, and this may have maximum 5 plus 5, so you are having 15. So scale factor is index factor by 3 parameters, summation of 3 parameters. So index factor we have set 100, and 3 parameters is 5 plus 5 plus 5, and that is equal to 100 by 15, and that is kind of like 6 point something. Okay, so we are having something like that. Okay, so this is scale factor. Now we are having this 5 plus 1 plus 3 for our particular project. So we will have technology is total new, so we are putting 5, very risky, and then our architecture is very simple, so 1, and constructability is 3. So if we add these 3 plus 1, 4, 9, and 9 times, let's say 6, so 36. So that is the maximum is 100, and we are having 36. Let's have an idea how good we are. So the scale factor is determined by the number of people expected to work on the project. So that is 6.6 is the maximum we have achieved earlier in previous slide. So if the number of people are more, so we will be using this. If the number of people are lesser, we will be using lesser factor for that. So using the suggested construction method, the index should be lie between 0 to 99. Projects below 20 are low risky, 20 and 40 are medium risky. So we are having 36, so our project is kind of medium risky. Okay, these projects are vulnerable and take a year or longer. Above 40, the projects have overruns and often are abandoned. So this is very important. So this method, you can customize this risk complexity index method for identifying the overall project risk for your own project, and you can have a customized setup for that. Okay, and then third method is there, and that is assessment grid, and this is used usually for intangible deliverables project or social sector projects and R&D projects. So for projects with intangible deliverables, the tool examines 3 potential factors: technology, structure, and size. So technology, whether the technology is well known, and structure, whether solid formal specifications, strong sponsorship, organizational practices appropriate to project, low when unknowns in staffing, responsibilities, infrastructure issues, objectives, or decisions processes. And then size, measured relative to the size of the teams that the project leader has led in the past. So each factor is assessed in a binary manner, just like the first method we have talked. So summing this thing up, we are using so many tools and techniques, and just giving you one example. So most critical risks are for the scope one, okay, and few of the risks which have been identified through the studies of years, that the following are few sources for the specific scope risk, and those include requirements that seem likely to change. Now that is a big hidden point for risk. So you should be very objective. The project stakeholders should be on one grid as far as requirements documentation is concerned. And there is second thing, mandatory use of new technology. So if I'm actually constructing this 20 building story, and you have completed like 5 projects of same nature, but for that I want this new technology. I just want to have laser guided lifts and cranes. So you haven't worked on that before, but I want you to. I am also very much of the interest that my building should be completed, but I just want to have that methodology adopted on my project as well. So that is kind of a source of scope risk. And requirements to invent or discover new capabilities. So one project is assigned that, and through that we want to invent and discover new capabilities. So that is kind of source of scope risk. So unfamiliar or untried development tools or methods. So you are not sure of those laser guided cranes and lifts. But you have to use that those tools. So that is also a source of scope risk. Extreme reliability or quality requirements, yes, that actually also can make your project a bit risky. By that time, your acceptance criteria will be very harsh, and you will find it very difficult to get the things approved as far as quality standards are concerned. So that will make your project a bit risky. External sourcing for key subcomponent or tool. So you are relying heavily on your suppliers, and one of the supplier has faced some financial crunch, and even if you actually pay a short part, complete part to that supplier, still he is not able to have arranged the materials or resources. So by that time you are left with kind of in a risky situation. Or you have to develop different components of one software, and then one of the components you have outsourced to this gentleman X, and he is not giving it to you on right time or on due time. So your whole project team is waiting. So that is kind of, and if then they actually come up with the software, and then you have come across that, okay, so that is not compatible. The software or the platform this guy was using is not compatible with the one you are using or your main project team was using. So, and then incomplete or poorly defined acceptance tests or criteria. This happens a lot, people to have different understanding of the things. Okay, I just wanted to get it approved after these 3 tests. This is as mentioned in your project documents. And दूसरा साहब कहते हैं ये कहाँ लिखा है कि ये 3 टेस्ट ही होंगे, ये तो आपने खुद से सोच लिया ना कि 3 टेस्ट होंगे. हमने ये लिखा है कि नेसेसरी टेस्ट वो कहेंगे, लेकिन नेसेसरी टेस्ट मैंने आपके साथ पहले भी काम किया है, वो 3 ही होते थे, लेकिन ये साहब कहेंगे नहीं, लेकिन इस पे हमने सोचा कि हम 4 कर लें. So that it should be defined very clearly. Technical complexity. Oh yes, if the project is Like if you want to construct 60-story building, then that is kind of a technically complex, and if you want to construct a dam, you know, kind of complex, and if you want to construct a bridge or road, so those are complex endeavors. Then conflicting or inconsistent specifications, somewhere that is reading something else, and the second time this is reading something else. Then the client may be focusing on that, and you are actually bringing the first one. Sir, madam, this is what is written in our specification. Then this guy is, this lady is of the opinion, no, we have to stick to that second one. So, but you have developed your product on specification number 1. So that is identify such inconsistencies as early as possible. And then incomplete product definition. So people are so much focused on doing the job, they forget having proper definition, documented definition. So very large WBS is a very good, is a very potential source of scope risk. So larger WBS, I mean, you're either you have more resources to manage them, or you are nobody to manage every work package, and few work packages are left with the responsibility. That is a big question mark. Then low profit contracts are very, very risky, you know. So profits are so low that you can your supplier is actually working on 2% profit, and the price hike of even 1.5% will force him to abandon supplying you the materials. Okay, so these are also scope risky. And client oriented contracts are very much if this is mindset that the contractor is actually you know, stealing some money, rather having this concept of he may have his legitimate and he has this right to profit, make profit out of the working. So when such contracts are out there, then that endeavor or undertaking is a very risky one. So these are few sources of scope risk. Similarly, there are sources of schedule risk as well. So there are delay risks, there are dependency risks, and there are estimating risks. And over the time, this is from one source from literature, and one study has actually shown that the delay risks have contributed up to average 2.3 week, okay, and then dependency are contributing like 5 weeks, and estimates they are contributing like 4.7 weeks. So the most significant risk as far as schedule risks are concerned are relationship types. As far as impact is concerned, okay, as far as probability is concerned, the delays are, you know, count is more than on as far as delays are concerned, okay. So sources risk, examples of resources. Among the resources most often discussed are manpower, information resources, machinery resources, equipment resources, software resources, and components resources, money resources, time resources, establishment, physical and organizational framework, services, communication, transportation, legal, access to consumable, power, fuel, food, etc. So these are few examples of resources. Then sources of resource risk are given over there. That is for people, outsourcing, and money. These are very highly highly ranked resource types. And over there you can see people are less risky than the money thing. So as far as money is concerned or cost are concerned, more risks are about costing. So there are there is risk in people, you know. So different types of people risk, like one of the risk may be staff leaving the project permanently, staff leaving the project temporarily, but when they are most in need, staff joining the project late, a non-dedicated staff, functional type of organizations. or weak metrics organization. So the staff is primarily attached to the this functional manager, and he or she is least bothered about the project because he or she does not have any opportunity to get promoted in that. So conflict between simultaneously ongoing similar projects. So we are having this resource named Aslam, और एक project manager कहते हैं जो मुझे असलम अगले हफ्ते चाहिए, और दूसरे project manager कहते हैं मुझे भी असलम अगले हफ्ते चाहिए. So फिर आपकी ये आ जाएगा कि देखा जाएगा, प्रोग्राम मैनेजर ये देखेगा कि किस प्रोजेक्ट के ऊपर प्रायोरिटी ज़्यादा है, जिसकी प्रायोरिटी ज़्यादा होगी वो असलम साहब वहाँ चले जाएंगे. सो दैट शुड बी ऑल्सो बी कंसिडर्ड. Low motivation, falling morale on project, that is kind of through strictness we can actually impart demoralizing concept. So we want to actually attend that. And then internal politics, that is very kind of risky activity. And then there are risks attached to the outsourcing. So few of them are given over there, like late delivery, like violation of specified standards, and protracted negotiations, turnover for service or product supply. So these are few outsourcing risks which may be considered while identifying the risk. So then there are money risks. So change in government, monetary policy can be changed, sudden change in national economic and financial policy, and displayer of international funding sources for the World Bank, ADB to extra. So that may, and then there may be a change in interest rate by the state bank. So this type of risk does not happen often, but when they happen, the effects are drastic. So these are few different types of resources, and there are few sources of these risks, different risks we have identified. So now we will move to a process. What is identify risk process? So we want to have risk management plan, and from where we get that risk management plan? Remember what was the output of plan risk management? The output was a baby risk management plan that is input to this very process. And then we are in need of activity cost estimate, and we are not going for the overall estimate, but the activity cost we want to get into it so that we can identify all the risk. And then activity duration estimates, then scope baseline. And what do you mean by scope baseline? Initially that was scope statement in plan risk management, but over there you are having scope baseline. What do you mean by scope? What is the difference between scope baseline and scope statement? So scope baseline includes scope statement, project scope statement, plus WBS plus WBS dictionary. So WBS dictionary is the explanation of work breakdown, structure, elements. Okay, so all these three make this scope baseline. And then we are in need of stakeholder register, and all the stakeholders, number, name, roles, their interest, their impacts, and their relationships, their networking, their communication needs, their stakeholder management strategy, everything is needed. Then cost management plan. So we are having cost activity cost estimates, and cost management plan is about budgeting and EVM stuff. Then schedule management plan, similar thing. Then quality management plan. Then project documents necessary to have explored for identifying the risk. Then enterprise environmental factors related to identifying the risk of a project. Then organizational processes, assets. How do the organization actually identify? Do they have a database available? So all these inputs, 11 of them are listed over there, are then actually considered. And then we apply documentation reviews, information gathering techniques like interviews, like surveys, like questionnaires, like Delphi techniques and stuff like that. We are going to talk on those in upcoming slides as well. So checklist analysis, assumption analysis, diagramming techniques, SWOT analysis, expert judgment, and then we get risk register out of this very process. So one of the example of risk breakdown structure, RBS, was discussed in the last class. So that is one kind of RBS. And another kind of RBS may be of that type. So if you can have an idea, so like if we want to divide our risk in two categories, and that is human systems and natural systems. Okay, so human systems mean includes social systems, political, economic, financial, legal, health, managerial, technical, cultural. So cultural risks, so as far as social risks are concerned, like one risk may be the criminal risks like criminal acts, then civil torts, and then substance abuse. So these may be further risks. So these risks are categorized under social, and social risks are categorized under human systems. So similarly, we may have war, civil disorder, and industrial relation actions as far as political are concerned, and then economic, materials supply, labor supply, equipment availability, inflation, tariffs, fiscal policies, and exchange rates. So these are related to economic risks. And then interest rates, credit rating, capital supply, cash flows, rentals, financial risks. And then contract clauses, regulations, and codes. These are the risk under these are legal risks. And then epidemia, surgery, these are if the risks are related to that, so we are having health risks. And then productivity issues, quality assurance issues, cost controlling issues, human resource management issues, all are managerial risks. And then design failure, equipment and systems failure, estimation error, collision, accidents, so all these are technical risks. And then we are having religion and cultural custom, so these are cultural risks. Similarly, we can actually group our climate risks over there, and geological risks, and then ecological risks and biological risks, and few other risks. So this is a very good example of a risk breakdown structure. Another risk breakdown structure, so if we can actually identify the types of risk in construction industry, so we are going to have a very good case study. So the construction industry risks are actually divided into physical risks, act of God risks, and design risks, and then political risks, and then environmental risks, then labor and site relation risks, then financial and economic risks, stakeholder risks, and organizational risks. So this is very important that these are few of the categories we have identified. There may be project management risks, internal organization risks, and external stakeholder risks. So we could have added a few categories over there. So this is developed just to have better understanding of few people on that. So as far as physical risks are concerned, so those may include accident on site. So one of the accident on site may lead to injury or death even, or some sort of establishment of a first aid facility. So that is accident on site response to accident on site risk. Then damage to equipment can happen due to one of the activity, and then damage to machinery can happen due to one or more activities, and then damage to infrastructure can happen, and then fire eruption may be there, and then theft may be there. So all these are a few risks as far as physical risks are concerned. So we have construction industry risk, and those are divided into physical risk. And then there may be act of God, anything which is beyond the control of human. Where such concept of the God is not prevalent in those societies, they usually use force majeure. They do not use act of God. But for societies where the concept of God is prevalent, they use act of God. So act of God risks may include floods, earthquake, landslide, fire, wind damage. So all these, but not limited to. So these include, but not limited. There may be a list of risks, which there may be opportunities as well. And then there is risk related to design. So engineering design risks may include, but not limited to, incomplete design, inexperienced designer, defective design, poor scope understanding, errors and omissions, inadequate specification, poor estimation, and stuff like that. And then there are political risks. If you are constructing this road, and few of these risks can actually influence your project by great margin. So that is disownership of the project. So I do know a few projects where the withdrawal of ownership actually halted the projects, and those projects were able to be completed in decades rather than in years and months. So then change in law and regulation. So you are taking up this project and you want to develop this software which once installed on gadget can record the whole conversation, but then there's arrived legislation that is prohibited, this activity is prohibited. So your development or your project is then halted. You cannot or you should not proceed with development of the same software, because if you develop, then you cannot even market because of the new laws and regulation. So requirements for the permits, if those are requirements are very high, then that is kind of risk. And then law and order situation. So you have taken up this project in remote area of the country, and their law and order situation is there. So then that is kind of risky. And new legislation, like changing the few values, or putting some bar on some business, like you wanted to have this project which would have used some 7-year-old vehicles through that project, but then government has put a bar and restricted only 5-year-old vehicles can be imported. So by that time your project has become a very risky thing. Okay, and then environment, pollution and safety rules. So for where you are constructing this building, the environment people have arrived, and they have actually monitored that what are the pollution level over there, and if those are going beyond the acceptable, so that then those are very risky endeavors you are taking up. And then overactivation of environmental agencies and NGOs, that is very kind of risky for construction industry. So poor environment impact assessment report at design stage can lead to a poor understanding of the stakeholders, and hence may lead to rejection of the concept. And then locals' emotions high due to damages to graveyards and climatic risk like rain, snow, etc. And labor and site related risk, labor disputes, stakeholders interventions, labor inefficiency, extreme site conditions, design changes during currency of the project, machinery equipment failure, and supply breakdown. So these are few labor site related risks. And inflation, rise in salaries, basic salaries and change in interest rate, escalation in materials cost, cash flows, exchange rate fluctuation. So these are financial and economical risks. And then stakeholder risk, withdrawal of acceptance, lobbying for rejection, protests, strikes, denying access to the site. These are few stakeholder risks. And demotivation of the team, leaving of team members, organization's ability to keep the project has been reduced, financial health of the organization has been reduced or undermined, or policies. These are a few organizational risks. So these are a few risks we have identified for construction industry in Pakistan. But then for very particular project, all of these risks or few of them can be utilized, and there may be another lists of risks available. So that's it. We have completed our today's lecture. Now let's have the summary of this very lecture. So in this lecture we have discussed about identifying risk and how identification and responding the risk is related to each other, and what is the benefit of early identification, why should we do iterative identification, and why should we place this provision of emergent identification. We have talked about in detail of scope risks, schedule risk, money risk, resource risk, and a few of the typical risk in construction as a case study of risk breakdown structure. And we have done that. The risk register is output of that very process. So that's it. Thank you very much, and good luck, and Allah Hafiz.